Hey guys, it's me, Mr. O'Brien, Mrs. O'Brien's husband, and Delmar, science teacher. So, I want to talk to you guys a little bit today about a term that we use in science called properties. I'm not talking about properties like your house or your car or your toys or things that you own. When we talk about properties in science, we're talking about characteristics or qualities, okay? So if I wanted to talk about, say, the properties of this balloon, what are some ways that I could describe it in a scientific way? Well, we could say that it's the color orange, right? That's a property of this item. You could also say that it's kind of elastic or stretchy. I can kind of flex it. That would be another good property of this balloon, okay? We could talk about the mass of something, or kind of how much it weighs or how heavy it is by putting something on a scale. So we could use one of these fancy balances, or we could use something like this, a spring scale. So again, you can kind of just clip something to it and see how much that pulls down and figure out what its mass is. These are all what we call physical properties. They don't change, okay? They're typically constant when we look at an item, okay? For instance, this is made out of glass. It's not just going to change all on its own, okay? That physical property is going to stay as is. But there's also something that we call a chemical property, okay? Now, chemical properties are things that we can observe about objects in our world, but in order to measure them or see whether or not they apply to something, we kind of have to change what we have in the first place. Now that might be a little confusing to you, so let me give you an example. All right. So in my beakers here, why don't you come up and get a little bit of a closer look. I've got these 3 different beakers, and I've labeled them A, B, and C. Now, if we just look at the physical properties of these 3 beakers, it's very hard to tell the difference between these substances. All 3 of them are clear, they're liquids, they tend to have the same density or kind of the same thickness, if you will. Just looking at these, I wouldn't be able to tell them apart one from the other. But instead of just looking at their physical properties, we could also experiment into what their chemical properties are. And we might just be able to tell them apart that way. Okay, so to test these physical properties, safety first. I'm going to put on my lab coat just in case I spill something on my clothes. And hold on one second, I'm going to get my eye protection too, because I don't want anything to get in my eyes.
Look at that huge bone.
All right, I think we're ready to go. So, one chemical property that some substances have is that they're flammable, or we can burn them, okay? Some things burn, some things don't. If I try to light my table on fire here, it doesn't catch on fire. It's not flammable. It doesn't have the chemical property of flammability, okay? Other objects, we could light them on fire, no problem. What do you think? You think my tape is flammable? Yeah, that's flammable. Don't try this at home, kids. All right, back to our 3 substances though. Let's see if we can tell them apart by looking at their flammability. If I try to light my substance A on fire, notice, it doesn't burn. It's not catching on fire at all. Pretty disappointing, right? If we take a look at our substance B here, look at that. It seems to be burning all on its own. Now, as we're doing this, we're also changing what substance we have here. Might be hard to see in the video, but right when I lit that, we got some condensation on the side of the glass here. Kind of some water vapor, because we're changing whatever this substance is into heat and water, and also we can't see it, but carbon dioxide. All right. Let's try our substance C to see if substance C has that chemical property of flammability. Whoa, that one's even more flammable. Did you see how quickly that lit and how much taller that flame is? Yeah, so this one is not flammable. It doesn't have that chemical property. B and C, on the other hand, those two are definitely flammable. Okay, so what do you think? Are B and C the same substance? Well, we still don't know. We do know that they're both flammable. This one's not, so we know that this must be something different than these two. And let me just spoil it for you. It's water. Ever try to light water on fire? Not gonna be much success. Okay, but how can we still tell B and C apart? All right, well, another chemical property is something called corrosiveness. That's a kind of a mouthful, but what it means when something is corrosive is it likes to kind of break down other things. Maybe you've seen like some cartoons where someone got acid and they got melted or dissolved. That's because acids are corrosive and they tend to kind of eat away at things. That's why I'm wearing this lab coat, because I don't want anything to eat away at the clothes I'm wearing. All right, so let's test the corrosiveness of these three materials. See if they have that chemical property. All right, if I put A here on my little styrofoam packing peanut, doesn't look like we're getting much of a reaction there. I don't think A is flammable or corrosive. Let's try B. It sure was flammable. We got a nice flame there. But it doesn't seem like it's corrosive either, okay? Let's try let's try letter C. Whoa, look at that go, just eating away at it, corroding it, and dissolving it into nothing. Okay, so we've looked at two chemical properties, okay? Flammability and corrosion. Substance A was neither corrosive nor flammable. Substance B was flammable but not corrosive. Substance C was both flammable and corrosive. So from this, I think that we can make the conclusion that these must all not be the same. They must be three different substances because they have different chemical properties. All right, guys, thanks for listening. See you next time. All right, guys, I've got a little bonus lesson for you. From that previous demonstration, I have a little bit of some leftover chemicals. Whenever you're working with chemicals, it's really, really, really important that you know how to dispose of them properly, okay? Not everything can go down the sink because some chemicals that we use in science are really bad pollutants. And if we just put them in the sink, they're gonna go down through our sewers and end up in our San Francisco Bay or other water supply, and we don't want that to happen. So, right now I've got a chemical that I used in my previous demonstration that I can't put down the sink. So what is one safe way that I can dispose of this? Well, I can actually burn it off. So you guys are in for a special treat today while I get rid of this. Okay. Again, don't try that at home, kids.